Okay, so welcome to Cisco Packet Tracer tutorial on how to build a small office or SOHO network with a branch network over a private metropolitan area network. So I'm not going to go through any of the um, introductory parts of the program. You need to watch the previous tutorial for that. There will be some new things that we are introduced to, and I will talk you through those. So we're going to be designing in the physical first, obviously, as we have been for the obvious reasons that if you just chuck everything in the logical, it all just appears in one place, which is very much not what we're going to be doing here. So we're at the outermost level in the physical. If you remember, if we control and use the mouse, we can zoom out and see that we have our city. I'm going to put the city here, and then I'm just going to leave it named Home City for now. I think in a scenario it might be Newport, Cardiff, or wherever. So if we click on city and then zoom in, we can see that we have. So when you think of a metropolitan means city. So uh, man and can are somewhat interchangeable. It's mainly the use that they're for. Campuses, um, you know, like Newport, for example, has multiple. Well, that's what you will find a lot with networking is that there's no definite description for lots of things. It sort of depends. So if we take Coleg Gwent, for example, that campus is much wider area than some other campuses, but they'd still be called cans because of the way that they're sort of configured as well. So you got to try and take everything with a pinch of salt in networking. So and computing in general as well, actually. So we have our city here, and we can zoom in on our office. It's a bit close. Okay. Um, so what we're going to be doing is we're going to be creating um, a second office and connecting the two. So we can go ahead and do that actually. So go back a level and uh, create a new building. So we're going to have two offices at different parts of the metropolitan area. And then we're going to connect them together over a network that essentially would be owned by another company, unless I was like Amazon or something and I owned infrastructure. So generally speaking, the internet is made up of lots and lots of essentially private networks to some extent that are borrowed and lent out in various different ways and bought by different companies. So your internet at home isn't free, for example, because you have to pay for the bandwidth essentially. So we have two offices here that we're going to connect with each other, and we can click into one of the offices. So it's going to be important with your assignments specifically that you are labeling things religiously, essentially. All right, cables, devices, rooms. All right, because the idea is that much like in programming, this is how someone is going to build something. Networking is a fair bit more sort of, well, I shouldn't say real life because programs are, but you have to take into consideration the physical boundaries of where you are. So we're going to add some labels to our rooms. Office 1. Now, the names of the rooms somewhat arbitrary, but and for the assignment, as long as things are labeled in terms, the most important things obviously are the devices, the IP addresses, cables, etc. But you have to have some sort of bearings. This is a business after all. So we've got Office 2, Office 3, and then we're going to have printing room. Let's just call this the lobby. Okay, so I've started labeling some stuff. I can change things and move things around as we go. But it's just so that we know, and you know more specifically, where things are. So we can zoom in and we'll call this the main office. And well, yeah, navigating. And we'll call this remote office. So let's go and just quickly. So we're going to add, while we're here, we are going to add a closet in here. And I suppose we should, that'll do. And then we need a office. Sorry, office. And I believe a let's just for now. Okay, so we've sort of labeled our buildings and our rooms a little bit, and so we can start moving on to devices. So we're going to go and start in the main office first, and we're going to start with, it doesn't really matter essentially which devices you start with. I'm going to start with my end devices. And we need also a wireless. So I'm going to start with the devices outside of the cabinet. So we're going to be using a gateway, access point, sorry, rather than a home router, so to speak. They are essentially the same thing, except a home router sort of acts as a switch as well, whereas this is sort of just a pure access point. So I'm going to put that in the hallway, somewhat central. Now you'll see that this turns purple, showing you the signal of your wireless. You can turn that off up here. So, so we're going to check my notes a second on what the printer. So we need a printer in the printing room. Printer, go in there. And we need 2 laptops. So we'll put the laptops in the lobby down here. And then the rest is in the cabinet. So we're going to go into the wiring cabinet and we are going to add a rack. Okay, well, whatever. So I've got a table and I've got my rack, so I can put in my start. Hang on, let's start with. Sorry, it's good to be somewhat methodical about these things so that you have some sort of system. So I'm going to start with a switch. So you'll see that it adds it. There's a power device up here. It just the number of devices, and then yeah. So just to explain what that is, that's added there. And then we'll go with a router. It doesn't really matter, just to sort of answer questions. Well, it does actually, because some of them are have many more features than others. But any of them probably do most, if all of the things that we're going to do, except 1 or 2 of them maybe. But we'll stick with the packet tracer stuff because it's designed for educational purposes, I guess. So packet tracer switch, and then we need a server in there, and I do believe that is all of the devices needed there. So let's just go into here, and we're going to have a wireless PC, and I'll put a printer in there. And then in the wiring cabinet we need so switch and a router. And while we are here, we are going to also do something a little bit new. We're going to change the physical configuration of our devices, particularly our switches. So if you click on a device, you'll be able to zoom in on the sockets at the back, and you can add or remove various sockets as you see fit. Although you do need to pay attention to so again, this is simulated for an exam, so you can't remove things when a device is turned on, and so you have to go through the process of turning devices back off and on if you're working with them in this way. So we're going to remove, so just to explain some of the UI here, because this is new. We have on the left hand side the different modules. Now it isn't the best UI in the world, all right, but you can click on the different devices here as I am, and then you read about. And it's very useful to read about all of the things within this program. There's lots of stuff. There's even test questions on your OSI model and TCP IP knowledge built into some of the interface. So, it does help to, and if you don't know what something is, then go look at. So you could click on the different modules there. Essentially, they're just various different speeds. Now, my instinct might just to be to go with the fastest of any type. However, cost is a thing. I suppose from a long-term perspective, perhaps it might invest to, pay to invest in better technology earlier on. But I am going to just stick with the basics. So we're going to go with fast Ethernet. We're just going to fill our switch so that we definitely don't run out of stuff. We've already got a few devices on this side of our metropolitan area network. So more important is going to be, oh no, I have forgotten. To switch this back on. So if something isn't working, check that you've gone and you switched it back on. Right, so we're going to do exactly this. We're going to do exactly the same thing over here. We're going to need a fair few of these. So the other thing you'll notice when you do switch things on is they take time to boot. So if you're trying to go into various things like this now, device is still booting. You'll notice this in logical when it's wired up. I'm going to sort this out later. When the little triangles are right, that might be because the device is switched on or the port isn't switched on. The sockets at the back. Okay, so I think that's that done. We need to go into the laptops and we got to configure these ones a little bit. So at the moment they just have so I suppose it shows the age. I think it's also because they want to show the what's actually inside your laptop, so that because people don't actually know. So we're going to remove the LAN port, or the additional LAN port, I should say. Although that might just be console, but by the way. And we're going to add a wireless area. So this is how you used to actually get wireless on your laptop. You'd have this aerial coming up and stuff. And that's not even really that long ago. And if you are working with satellites, then you have to have this kind of equipment as well anyway. So we've added that. We need to turn that back on, and we need to do the other laptop. Turn that off, take that out, put that in. As you can see, there are other things to choose from here. Different ports and stuff that you can add. Right then. So we can now add the connections to devices. Let's click on this. So we are connecting devices to switches, so not together. So we are going to be using straight through cables for the most part. So rack. So I'm going to go into the switch. Now you should try and have some sort of method to what you're connecting with, so you can remember. But there are ways to display the ports, which I will show you later. That is very helpful. So without further ado, let's connect these things up. Such. So console, if you're wondering and you've seen that, is basically a way of it's like a one-way way of sort of monitoring using a console, which we don't need to get into with this. Oops. I'm just going to add things first before I start fiddling around with this. So when it comes to the wiring, it doesn't need to be wildly complicated. It just needs to be sensible. In the sense that you want to bunch them together so that things are along walls or parallel to walls, and then so it would be along the ceiling and or along a wall. You don't need to go around, because you're just increasing the distance of the cable, which will slow things down. And also you'd have other cables for the lights and various other things in the ceiling, which is essentially what you would be following, so that it's easy to keep track of where things are. So we've got 1, 2, 3 PCs, 2 laptops, and then we'll go and we'll wire up here. So I'm going to try and label some things as I'm going, but I won't have, you don't want to watch me, it's bad enough this, you don't want to watch me sit here typing in the labels for all these things, but you will be expected to do that for the assignment. Right, so I've got those two hooked up there. Right, we now need to just have to think a second. So I'm a little bit finicky when it comes to these things, so I'm just going to reorder these cables a little bit so they're less a bit more organized. Right, so I've done that bit, that bit, that bit. Okay, so that's that. You'll notice the only thing we have left to do is connect the two buildings together. So let's do, now for this, we're not going to be using Ethernet, we're going to be using fiber optics because of the distance. So I do believe this is how you do it. Otherwise, I'll go and do it in logical. There we go. One more attempt. So, main wiring closet, rack, router, fast Ethernet. Go down here. Wiring closet, rack, router, fast Ethernet. And so the last thing to do then, in terms of our physical setup, I do believe, is to simulate the wiring that you might have in a metropolitan area along the roads. So we are now ready for the logical. Just notice that the ports are not on for our fast Ethernet while we are on it. So let's go and turn that on. So as I said earlier, some ports are not on by default and don't turn on when you plug something in. So we got to go and switch them on ourselves. So you should have everything green, and then you know everything is connected correctly and switched on. So we can now actually head over to the logical mode, and you'll see what a mess they've made of this now. So we need to just try and sort some of this out so we can see. Now this is obviously again why it's important. Haha. There you go, something I missed. I'll go and connect that in a minute. So this is why obviously it's useful to label things so that you know what is where. So that is our remote. So start labeling just a couple of things so I know what's what. So if we sort of, I suppose, roughly copy the layout that we have in the, my goodness, in the building. I think I've made a mistake there. Oh, I haven't turned it on. Right, and then I need to connect this, which I missed. I can connect that in this. You can connect things in this mode obviously as well. However, like I said, with the physical, it's better to do the physical first, because when you add things logically, it literally just it's easier to organize the logical than it is to reorganize the physical, and that's true in real life as well. Right, so I think everything's green there. We do need to connect the server. So that's why we need so many connections on the switch. And so everything should be ready to go. So just a quick note before we start on IP addressing is that we're going to be using a number of different networks, names of networks. Now, they might not necessarily be exactly. A lot of what we're doing is simulating essentially what might be used in real life. You also have to remember that they don't use classes so much, or if at all anymore. However, we do. Well, we'll come to this in a minute. We can use classes in our mind to keep things organized, but yeah, we're going to be using just to really show essentially how different networks connect to each other. But it might not necessarily be exact. It depends on the situation. So we're going to add, I'm just going to add a couple of notes here to keep things clear for yourselves and myself as well. So we're going to 116. Point 116 star point star network. Whoop. So that's the 172.16 network over there. This is the 10 star. So you can fill in the stars with zeros essentially, but I suppose that's not technically correct, I suppose. Let's not get into things like that. And then so that's the middle network here. And then this network over here, our local network, or main office network I should say, is going to be, got this the wrong way around, not concentrating. Oops. Interfaces. So so this is going to be 192.168.0 point star. Let's get rid of networks, that's just confusing. Press escape, there we go. So 192.168.0. So this is common because for smaller networks, because it's the smallest number of hosts. 10, popular for the largest networks. So that's going to simulate our sort of metropolitan area network / wide area network. And then this is going to be our local, but so these two local networks, essentially, this is going to be our other local network, but a larger one, which has a larger number of hosts available to it. So let's go in and start over here. Let's not start with that one actually, because that would be a bit confusing. Why are you not starting with one? So let's start with the router. All right. So this is the default gateway. So this point here for this network here, and then these two gateways between there, and then this is the default gateway for this network here. The default gateway is usually the sort of router that you want to connect to in order to get to a different network. So we're gonna, and it is useful to name this consistently, so we're gonna go with 1 over there. While we are here, we might as well actually do the Ethernet, the fiber connection as well. So 10.0.0.1. So that is this point on the router. So remember, routers will have multiple IP addresses, unlike other devices, which essentially we only have one. And then the router maps or routes one connection to another, and that's what the router is. So we've got 2 on there. Let's do this router then while we're here. So fast Ethernet 4, where the fiber optic comes in, will be 10.0.0.2, because you don't want to have these, even though this is a small network of its own, so you can't have the same numbered devices. And then on the 172.16 network, and then 0.1, and that is this connection here. Okay, so we've done our routers then. Let's go over here because it's the fewest devices, 192.168.0. So in some of the other tutorials we will be introducing some of these other options, but that's all we need at the moment. However, see me. So the default gateway, is the router. Concentrate where I'm typing. The device address for this. So when we're doing the device addresses, you're actually doing the address for the port. Yeah, so that's why it's under the the fast Ethernet rather than the name of the device. So IPv4 address for that is 192.168.0.2, as I was just trying. Okay, the default gateway, as I said, is the router. That's this point here, which we named as 192.168.0.1 when we configured it. So we're going to point all of the devices to this point, and then all of the devices on this side to that point. Let's go to the printer. So this will need a gateway as well. So 192.168.0.1, which is our router. Our port needs to be 192.1. Oops. Right, so when you are giving host numbers, you might want to group devices together. All right. So I've just realized that I just haven't done that with the other one, so I'll go back and do that. So let's do this first. So 192.168.0. So I might want to have all my routers and various in certain groups of numbers, and then other devices like servers and stuff in other groups. So I'm going to put this at 15. So that gives me some room between one, which are my routers, and then I'll have some other devices in there, and then printers and stuff, and then other devices. So like I said, it doesn't particularly matter as long as you know which numbers and are labeling which devices you've numbered what. I'm just going to go back to the PC here, and I'm going to, instead of naming that 2, I'm going to go backwards from the highest numbers. The highest number is 255. Don't use 255 because it's a lot of the time can't be used and conflicts with the subnet mask. So we 254, and then we can work down for if you will, like sort of client devices. Yeah, so small devices that are just pure end devices. Yeah, so 254 on there, and then we can have printers, for example, might be between 15 and such. Hopefully you get the idea. So we've done that side. Let's go and do this side. Let's try and I want to make sure that everyone understands what we're doing, which is why I don't want to just see, I'm not concentrating. Don't want to just fire ahead without clarifying things. So default gateway on this side is going to be 0.1 of the 172.16 network, which is this point here on the router. So this is an end, so 172.16.0.254, because this is just a PC. Let's do this one. I can probably, as you can copy that, because I'm going to be using it. 2.16.0.253. It's hard work, or it's tedious, but when it all works, it is satisfying. So 25352. Let's do printer. Let's put that one at 15. And then server, gateway, port. Let's do that at 10. And then we need to do our laptops. So we'll come back to a lot of the configuration for the laptops in a minute. Also, if you're doing the more advanced version, DHCP means we have to configure things a little bit differently. So there's lots of options, but let's stick to what we need. So 25225.1 DHCP obviously has the benefit of not having to not having to statically, because if anything changes you gotta manually go in, but this is the easiest to understand, and you gotta know this walk before you run. So I think we have all of the IP addresses are assigned. I suppose we'll soon find out if not. The last thing we need to do is configure our routers to root. So under routing, so this is sort of the main purpose of the router is, so there's static, so we'll do this in the more advanced version, we can individually direct traffic to where it needs to go, which is more secure. Or we can use dynamic routing, which is easier and also useful if you're sort of just adding various, if you're changing the network, there's sort of less to configure. So what we do here is we put in the networks that we want to route, and then it will map one over the other. So each of these routers uses the 10 network, so we add that, and we are on that one over there. So this one is connected to the 192.168. So just think of this as the traditional old switchboard that people use to connect wires into, to connect one place to the other, and that's essentially what we're doing here. 0.0. So we're not putting in the host numbers in at the end, we're just putting in the network part of the address. So in this case 192.168.0. In this case it was just 10, and we add those. So these two are now mapped or router IP'd together. Let's do the same on this side. And that should be everything configured except for our wireless. Yes, I have to remember. So when you are configuring the wireless here, the default is that it will just connect. But the problem is if you have multiple access points, and you have devices that you don't want to connect, so guests coming in, then you want to be able to control the security of it. So if you click on the access point and then go to port 1, should be, and so you'll hopefully recognize some of these. So we've got an SSID, which is basically an identification of the network name that you are connecting to, and so we can call this main office Wi-Fi, and we can have different authentications. This is basically username and password authentication encrypted. So we're going to use wireless protected access and per pre-shared key. So we need to make a password. So we're just going to call it Soho password. So you'll see now that the two laptops are no longer able to connect. So we got to go in, and so the easiest way to do this, all right, before, is not to go into this and start trying to connect using this. I've found that, at least the last time I did this, that it's easiest to connect. So you go into, rather than config, you go into desktop. So just go out a minute. You click on PC wireless, okay, and then connect, and then yeah, there we go. It's found it. It says 18%, but I'm sure in real life it wouldn't be quite that bad. Right then, so WPA2 personal pre-shared key. So this is where we add our password that we made, and then we connect. And then, as you can see, our laptop is now connected. So desktop, PC wireless, connect. Get my own password wrong. All right, so let's go back to our physical a second, and then we will move our access point over there. So we should be ready to do some testing now. Let's go out of here a second. So we are going to go from, let's just check that. So let's try from this PC to a laptop. So if you hover over things, you should be able to find out. So I've just seen that my laptop seems to have lost its settings when I was fiddling around with the wireless. So we've got to go back in here. 172. No, hang on. Yes, it's large network. 172.16. Ugh. 172.16.0.1. Our router. Copy that. Right, wireless. So we changed the password. It was 251. Gateway is 250. So, right, let's go back to where we were. So we're going to go into this, let's check where we are. So this is 252. So we are going to try and ping 250, which is one of our laptops over here. So we'll be logging all of this into a test table, which you'll have a template to help you start off with that. We'll also be able to run some other tests, including HTTP as well. Let's start with just trying our different devices. So we'll go into command prompt and we're going to use ping 172.16.0.250, which is our laptop. And we are getting replies from our laptop. So we are going from the office, one PC here, to the switch, essentially to the router, and then back out again, then to the access point, and then to the laptop. Let's see if we can connect to our remote PC. So that's PC over here. So let's just go check the IP address of this. So 192.168.0.254. So let's try a different PC. So our tests hopefully are that much more thorough. So we are, let's just check where we are a second. So this is 254, but 172.16 network. So we're going to ping 192.168.0 network and then 0.254. Just might take a little bit longer. That's if we haven't made a mistake somewhere else. That's definitely... So sometimes it does take a little bit longer, but it's quite possible that I have forgotten to configure something. So, I got these the wrong way around. So that's 172.16.0.0. I seem to remember doing that wrong. So that's good to get things wrong because you know how to fix. So in this particular case, I had mapped the 10 network onto this network, but that's not connected to this router. It's the 172.16 network. So I mapped 10 and I need to map 172.16. Let's just check that this router is correct. So that's 10, yeah, to 192.168 because that's what's connected to it. So we shouldn't have a problem now. So which PC was it again? This one? Yeah, right. So let's try again. Hey, that was quick. All right then. So that works. So that's why we test things, to make sure that we haven't missed something. Right. So we can let's test. One more PC to our printer, our remote printer. So that is 192.168.15. So let's go from this other laptop. So 251. We're going to ping 192.168.0.15. So we're pinging our remote printer. So you can see the request timed out the first time, so there's a bit of a delay because of the distance and probably because of the wireless. But we got there in the end. Let's just see if our signal has increased. 41 moving it. I mean, that's pretty close, so I don't know. I'm sure it'd be better than that in real life, but okay. So that is it for testing there. We do need to test our HTTP service. So just to go into our server, which we haven't really interacted with at all yet. So if you go to server and then services, you'll see a number of different services that will be interacting with HTTP, for example. So that's hypertext transfer protocols. This is sort of the beginning of the internet, is being able to transport text from one place to another. And we traditionally are familiar with this as being a website. So let's use some of our knowledge that we have gained over the last few classes. So we're going to go to a PC here. I'm going to go to desktop and we're going to go to web browser. And so what is an IP address? Well, it is a telephone number to a particular device. And so that's what our URLs essentially are. So we're going to type in the URL or the address of our server, which is 172.16.0.10, and then we press go, and that should show a website that is located on the server. So just a sort of proof of concept, we'll go into our server and we can go into our index.html, and instead of welcome to Cisco Packet Tracer, we can say welcome to small office with branch network over private man tutorial, and then we can save that. Obviously we can go in and essentially add a full-on website or intranet, as it probably would be more useful to have in a company. So let's just go and check this. And we can check this with a different device. So let's go and check this with our remote PC. So say, for example, we want to use the intranet services to have sort of web pages that portals the staff can log into and do various things. Might not be able to transfer files or whatever, but they'll be able to do quite a few things. So let's go to desktop, web browser, and then we're going to type in. Oh, we will have a look at doing domain names. So, sorry, concentrate 172.16.0.10. There we go. So welcome to small office with branch network over private MAN tutorial. So that's essentially an intranet in this case. I could then obviously in real life you might have that then would be routed through to your ISP as being your public-facing web address, or you might have a different server which would most likely deal with the public-facing part of your website, whereas you'd have your internal server then, which would deal with internal affairs for the company. So I'd log all of that information then into my test log, testing different testing the devices connect and testing my HTTP. And so the last thing to configure and test will be the DHCP service, which is relatively straightforward to do. We're going to do that in the main office. We're going to do it on the laptops. There's a couple of things just to note about DHCP. So what it is, so it's Dynamic Host Configuration Protocol. Basically, it means that when you add or remove devices, then the IP addresses can be assigned dynamically rather than statically, which is what we've done so far. That's obviously useful if you have like mobile devices that are going to be added and stuff. There's a couple of reasons why you might, or there's reasons why you might not. Mainly security, in the sense that static IPs require someone to manually do something, whereas anything that's dynamic or automated might mean that you have people connecting to the network that you don't know about. So, but we use it obviously because otherwise you could employ someone all day just adding and removing IP addresses. So we go into the main wiring cabinet and we'll click on server and wait for it to load. And we're going to go to services again. So HTTP, we're now going to look at DHCP for version 4. There's obviously the one for version 6. At the moment it's off, so we're going to turn it on. You can leave server pool as default. So the default gateway, so this is going to be the gateway that you're going to specify all the other devices that you're providing the service to, where the gateway default gateway for them is. So in this case it's 172.16.0 and it's our router again, so 1. Alright, starting IP address. So the start IP address is essentially where do you want the dynamic assignment to begin. So again, we're going to think about the fact that we might have other devices. So I'm going to say that, routers are 1 through such and such. Printers, remember, started at 15, we had server at 10. And so, and I've got devices then immediately connected as 254, 25, etc., etc. So if I go up to 255 or higher than 255 here, then this goes to 1 because remember, this is the host. These two are the host addresses on this, because these two are the network addresses. So I could put all my laptops on this network, or if I predict I'm going to have a lot of smaller end devices in the future, then I could put laptops starting at, for example, 5, and then subnet mask, I'm going to leave that as it is, because you can see here, so these are the network addresses, and this is the host numbers. Maximum number of users, I'm just going to leave default, and we just save. And that should be it. Now, the only issue really with DHCP, and you will know this from daily life, that the devices don't always, depending on the order in which device is turned on and whatever, you don't always get assigned a correct IP address by the server, and so you're unable to connect. So at the moment, we have our so we got to, yes, obviously change this. So at the moment, we've got both laptops set up as static. So we're going to switch that to DHCP. Now, when you do that, it should do that also on the IP configuration as well as the gateway. So we can check our gateway. You might need to switch windows, but you can see the gateway has now updated to 172.16.01. So that's our router. And if we click on wireless, go down to the IP configuration, is auto selected DHCP and 172.16.5. Yay. So let's just go and check our other laptop. And go in here, switch that to DHCP. Let's see, it's updated, and then 5.2. And then we obviously need to test that we can reach 172.16.254. So 2.16.0.254, and then we get a reply. So we can now add and remove devices, wireless devices. So I suppose we could just test that out quickly. Let's grab a third laptop, turn it off, swap out the wired for the wireless. DHCP is already configured there, but we do need, so you'll see that we have DHCP configured, and down here it's selected a default, I think it's an internal address. Basically, there's a certain range of IP addresses that are used for loopback. Anyway, I just have to figure out remember what my credentials were here. Main office Wi-Fi. Oh yeah, hang on, before I get stuck up with that. Desktop, wireless, connect. I keep trying to, yeah, so just to refresh with you, yeah, don't configure your wireless in on the laptop side from in here, it's much more foolproof and safe-proof, and less buggy for that matter, to do it through the desktop app. So you go to desktop, PC wireless, connect, just like you would at home. Search for the wireless, select it, connect, put in the password. So was it Soho password? Obviously you would not use a password like that. Should Hey, there we go. Looks like it's connected. So let's go and see. Yeah, there we go. So 172.16.5.3. So our new laptop has been connected successfully. Oh my goodness. So obviously all of that then I would put into my test log. And so that brings us to the end of our tutorial. Thank you.